The last section of chapter 2 is an introduction to relations and functions. So the first thing I'd like you to think about is when something functions, it works. What do you need to function, right? You need air, you need food, you need lots and lots of sleep because we're college, right? So that's what we need to function. If something functions, it works. There's an input and there's an output, right? You put in air, you put out carbon dioxide, okay? You need sleep to recover so you can put out energy. When I think of something functioning, I like to think of my favorite thing, which is coming up in just a second. So a couple quick definitions so that a relation is any set of ordered pairs. Remember, ordered pairs are like x1, y1. And a function is a relation in which for each distinct value of the first component of ordered pairs, so the x value, there is exactly one value of the second component, i.e. each x has only one y value. And if this is a weird concept to understand, you are not alone. And that brings me to one of my favorite things, the vending machine. A vending machine is a great way to express a function. So you've got your buttons, right? You've got like C6, D7, E5, right? And you push those buttons and you get something out. You might get chips or you might get a Snickers. There's an apple in here. I don't think anybody wants that apple. We'll put an apple, right? And what happens? You push C6, you get chips. You push D7, you get a Snickers. You push E5, you get an apple. So each distinct x value has only one unique y value. And this functions. If I was to have a vending machine, we'll make this an evil vending machine. We'll draw it in red. If I was having a vending machine where both C6 and D7 went to, got chips, Snickers, E5 was an apple. So if I was to have a vending machine where both D7 went to chips and D7 went to Snickers, when you push D7, what do you think happens? You aren't going to get out chips and a Snickers. That's what you'd like to think, but you won't get chips and a Snickers. What happens is your vending machine breaks down. This is not a function, right? This will not function. Meanwhile, in blue, this would function, okay? Here, this x has more than one unique y value. Let's look at the last example of a function. So my vending machine would still function if I had two buttons, C6 and D7. If I have two buttons going to, okay, here's E5, goes to an apple. Okay, my vending machine would still work if I had C6 go to chips and D7 go to chips, right? Here, each x still just has one y value, but this y value can stand for two x's. But this vending machine would work. Maybe chips are really popular, and we want to put lots of chips in our vending machine. So these are the two examples of functions, and this is an example of a non-function. So relations are sets of ordered pairs, and they can either make up and define a function or not define a function. So a relation can be defined not only as a set of ordered pairs, but as a table. It could be a graph. It could be an equation or a quotient rule. So for example, y equals mx plus b. This is a function. Each x has exactly one y value. The domain of a relation is the set of all possible values of the independent variable x. And our range is the set of all possible values of our dependent variable y. So domain is our x values, our range is our y values. So when we've got our vending machine, our domain is all possible x values, so that's all of our buttons that we could push, right? And like C6, D7, etc. Our range is all of our possible snacks and beverages. So why don't we state the domain and the range for each of these three relations and determine if they're a function. So for number 1, the domain, which I'm going to write D, is 1, 4, -1. My range is 2, 5, -2. You know what I'm saying? How am I going to determine if this is a function? Well, let's go ahead and make a picture. So I have 1 going to 2. So when x is 1, y is 2. When x is 4, y is 5. And when x is -1, y is -2. This is a function. Each x has exactly one y value. Now let's take a look at G. My domain is -3, -2, -1, 0. My range is 5. Well, 5 appears again, and that's okay. Remember, we don't write it twice in a set. 4 and 1. So let's draw a picture to determine if this relation is a function. I have -3 go to 5. I have -2 go to 5. And that's okay, right? If I push 3, I'd get a 5 out. If I push -2, I'll get a 5 out, and that's okay. I've got -1 go to 4 and 0 go to 1, so this is a function. Last but not least, I have my domain where x is -1, -2. Oh, I've already got a -2, so that's my domain. And my range is 0 to 1. If I draw a little picture of H, I have -1 going to 0, -2 going to 2, and then I have -2 going to 1. If I push -2 on my vending machine, what do I get out? Do I get out a 2 or a 1? We don't know. So this is not a function. Besides making a table or drawing a picture, another way to tell if an equation is a line is a function is by testing it with the vertical line test. So if every vertical line intersects the graph of a relation at no more than one point, then the relation represents a function. So for example, here's a linear equation. Each vertical line only intersects exactly once. Here's a parabola. We're going to get to those eventually. If I do the vertical line test, again, my vertical lines intersect our graph only once, and the same is true for my graphs down here. Here are some examples of things that are not functions. They're not a function because here my graph intersects at 2 points. I've got two y values for one x value. Same thing holds true for this circle. Here's kind of an absolute value function. It's been rotated. And here, there's not just 2, but there's 3 y values for one x value. So these are not functions.